So I'm the CEO and founder of Flowtype. As mentioned, we are backed by Andreessen Horowitz, Yuri Milner, and a long list of other investors, including Salesforce.com and others. Over the past 2 years, I've been working on some very interesting technologies with a team of engineers from the University of California, Berkeley, where I studied electrical engineering and computer science. But before I get into a preview of our technology, I want to talk a little bit first about where we see the internet going and what our vision is. Today, we live in an ever-connected world where, thanks to the internet, and really mobile plays a huge role in that, where you've got 1 billion smartphones, you've got 6 billion mobile phones, and this allows us to stay connected to the internet on the go 24/7. And this means that there's a huge amount of real-time data flow, enabling us to make better, more efficient decisions. And this can be seen in a variety of different use cases. You have things like Twitter, where people are now tweeting about earthquakes and disasters and breaking news within seconds of them occurring. This allows people to react smartly and offer help and shelter for those in need. But we need to think bigger than that. We need to look at embedded devices, where devices, tiny little sensors, are connected using mobile infrastructure and enable a completely new, completely bigger vision of things. You're starting to see this already, where cars, which traditionally were just analog devices, are now completely digital with thousands of computers inside of them. And now these thousands of computers are actually connected to the internet. You can unlock cars, locate cars, and even remotely test them out and detect errors using the internet and your phones. And phones. That's another thing. Just 10 years ago, the mobile phone allowed us to stay connected on the go. But now you have smartphones. Smartphones allow you to talk to the internet and get real-time data like you've never been able to do before. But again, think bigger, right? You're looking at now tens or hundreds of billions of sensors over the next several decades, enabling applications we can't even begin to fathom right now. We're talking about earthquake sensors that can detect an earthquake in a building or city before you even have the chance to tweet about it, which I know that'd be amazing. And this will allow us to hook them up to appliances and shut them down, hook them up to the power grid and gas lines, such that in the event of an emergency, in the event of an earthquake, we can turn off the power and gas lines and prevent casualties, fires, and further catastrophe. We need to think about this more. This is a very common, widely known vision known as the Internet of Things. People have thought about it for decades, but finally we're actually starting to see that happen. First with cars, now with phones, and many other things. But the question that we'd like to answer, and what I've spent the past few years working on, is the technologies that are going to enable this to happen. Not the applications that can do this, like cars or phones, but really what's going to power this? What's going to enable billions of messages of data to flow around every second in the world? Now, this requires huge infrastructural changes in the world before the Internet of Things can come to fruition. First, hardware infrastructure. We fundamentally require better telco networks such that we can handle larger amounts of data. And this is something that we've been struggling with over the past decade. Smartphones especially have created such a large amount of bandwidth requirements and a large amount of data that we need to revamp our infrastructure. And this is a hardware and software problem that we've been dealing with for a while now. But assuming this is solved, this is something that telcos like AT&T and everyone have been dealing with. Assuming this is solved, the next problem is also data storage. If you have the infrastructure to create billions of messages every second from sensors and phones and cars and buildings, you need to store that data somewhere. You need to be able to do something with that. The cloud has enabled this. The cloud allows you to do a lot of fancy storage without having to own data centers yourself. But even then, we're talking about storing amounts of data that are created every second that didn't exist just a couple years ago. But let's assume that this problem is taken care of over the next decade. There are companies working just on this problem. The next interesting problem is data communications. And that's where Flowtype plays a big role. That's what we've been working on over the past few years. And we'll be announcing a couple technologies over the next year to improve data communications in the upcoming world. With data communications, I'm talking about how data actually flows from devices and sensors to other devices, sensors, servers, and networks. So it's a software infrastructure. Assuming we have the telcos and the infrastructure behind the pipes to actually send data back and forth between servers and devices. The actual software required to do that is very complex. In some sense, it doesn't exist today. The only pieces you could use would require you to spend years developing it yourself, cobbling together pieces of technologies to somehow get a solution together. But Flowtype is solving this problem, and we call it Bridge. With Bridge, we've enabled real-time communications in an enterprise-grade, massive-scale manner between any device, any server, any machine, in any language. And this is a piece of software infrastructure that programmers in enterprises, in startups, and even individual developers themselves can use to go ahead and build very complex internet applications. And these internet applications can range from anything, anything from video games. Imagine playing popular, massively multiplayer video games with hundreds or thousands, or even millions of people, all in real time on your phone. Playing a game on your phone while on the go, on a train, that's a lot of data hitting your phone and hitting servers every second. We abstract away the complexities behind such infrastructure. We built that for you so that you can use Bridge and go ahead and build your game very easily with very few lines of code. Other applications include fleet management and shipping logistics. You have pieces of data coming in from sensors that are embedded in all your trucks. You have servers in some data center somewhere. And you have your business logic and intelligence in dashboards. How data flows between these various different devices, these machines, how things communicate with each other, is now abstracted away using software like Bridge. It makes it easier for these devices to talk to each other, making developers' lives and programmers' lives much simpler. They have to spend less time, they have to write less code, and it's just cheaper and more efficient to build these complex architectures because we've done that once, we did it right, so that you don't have to do it yourself. And with this architecture, you can take it to other applications as well, beyond gaming, beyond fleet management and logistics. And you can start looking at things like financial services. You can start looking at how we can use this to power the earthquake sensors that we talked about earlier. How we can take data from sensors in the city that are embedded in the ground and in buildings, take parking information and traffic information, and use that to make real-time decisions. Using Bridge, we can allow you to figure out the real-time location of every single car in a city in real time, every second. And using this powerful information, you can turn that and build a dashboard such that you can now provide emergency providers with the exact traffic route that they should take based on real-time information. And this is just the tip of the iceberg. Using Bridge, you can do anything. You can take this and build any complex internet application. You can handle billions of messages per day. You can handle all of this without writing much code, which allows your engineers to work on what's important, the product. With Bridge, we have abstracted away the hardest problem, which is data communications itself. And that's what we've been working on over the past couple of years. Over the next month, we'll be releasing a public version. If you go to our website, flowtype.com, you'll be able to see a preview of our technology and access it yourself and provide your engineers and developers with a beta version of our software. And with that, I'd just like to conclude that what we've built is a beta version of something that can really power the future of the internet, something that can allow really complex internet applications to be simplified, which means you can build very complex architectures very easily and achieve things that we can't even dream of today. Thank you.